December 14th, 1943. Admiral Matome Ugaki's hands trembled as he spread the captured blueprints across the table in his private quarters aboard the battleship Yamato. The intelligence officer had delivered them with unusual urgency technical drawings of the American Essex-class aircraft carrier, extracted from a downed pilot's belongings. The room fell silent as Ugaki and his senior staff studied the plans. "Impossible," whispered Captain Toshikazu Ohmae. "No shipyard could maintain this schedule." The plans revealed something beyond the carrier's dimensions. They showed America's industrial capacity in stark, undeniable detail, a nation capable of building 24 fleet carriers in just 4 years, while simultaneously producing battleships, cruisers, and thousands of aircraft. Japan's entire naval construction program had managed just 8 fleet carriers in the previous decade. Ugaki's face darkened as the implications became clear. Japan wasn't just fighting ships and men, it was fighting America's factories, shipyards, and limitless resources. "This," he said quietly, "changes everything. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you." October 5th, 1921. Kure Naval Yard, Japan. Naval constructor Lieutenant Commander Keiji Fukuda stood before a planning board covered with blueprints for the Imperial Japanese Navy's newest aircraft carrier designs. The Taiho was Japan's most ambitious carrier yet, incorporating armored flight decks, improved damage control systems, and enhanced aircraft capacity. The expectations among the gathered admirals and engineers were clear. Japan needed carriers that could match or exceed American naval power in the coming conflict. "Gentlemen," Fukuda began, "the Taiho represents the culmination of our carrier development program. She will be the most advanced carrier in the Pacific." Specifications were impressive: a displacement of 29,300 tons, capacity for 84 aircraft, speed of 33 knots, and an armored flight deck that could withstand direct bomb hits. Expectations were high in the Imperial Navy. After a decade of naval development, Japan believed it had achieved qualitative superiority over the Americans. The gathered officers nodded in satisfaction. Admiral Isoroku Yamamoto, Commander-in-Chief of the Combined Fleet, studied the drawings intently. "How many of these vessels can we expect to construct in the next 3 years?" he asked. Fukuda hesitated. "Current plans call for 2, possibly 3, if steel allocations are increased." Yamamoto's expression revealed nothing, but several officers exchanged glances. Japan's strategic plan relied on quality over quantity, superior ships, superior training, superior tactics. The Taiho embodied this philosophy: complex, expensive, and time-consuming to build, but theoretically superior to anything in the American inventory. What none of them knew was how fundamentally this assumption would be challenged within 18 months. The cause and effect relationship wasn't yet visible, but already taking shape: American industrial capacity versus Japanese craftsmanship. Mass production against precision engineering. The outcome would be decided not by the blueprints on that planning board, but by the capacity of shipyards thousands of miles away. In Norfolk, Virginia, the USS Essex was taking shape, the lead ship of a new class of American carriers that would reshape naval warfare. The blueprints for Essex had been finalized in early 1940, calling for a 27,100-ton vessel capable of carrying 90-plus aircraft. But unlike the Taiho, the Essex wasn't designed for individual excellence. It was designed for reproducibility, to be built quickly, efficiently, and in numbers that would overwhelm Japan's carefully crafted fleet. An archival fragment from the Japanese Naval Ministry's 1941 strategic assessment states, "The Americans may build more ships, but our vessels will be superior in quality and crewed by more experienced personnel. Their industrial advantage is offset by our tactical superiority." This assessment would be tested under combat conditions sooner than anyone expected. Fukuda continued his presentation, highlighting the Taiho's advanced features: the hurricane bow for improved seakeeping, the sophisticated damage control systems, the reinforced hangar deck, each feature represented Japanese naval engineering at its finest. Each also added months to construction time and thousands of tons of steel to the design. "We anticipate completion in early 1943, Fukuda concluded. "She will be the most powerful carrier in the Pacific." The cause and effect relationship was already established, though invisible to those present. Japan had chosen a path of qualitative superiority, believing that better ships could counter greater numbers. The United States had chosen mass production, betting that standardized designs built rapidly would overwhelm any qualitative advantage. Both nations were preparing for war according to their industrial strengths, Japan through craftsmanship, America through manufacturing scale. May 1942, Imperial Naval Headquarters, Tokyo. Admiral Osamu Nagano, Chief of Naval General Staff, studied the battle reports from the Coral Sea. The carrier Shoho had been lost. The first Japanese carrier sunk in combat. More concerning was the damage sustained by Shokaku, which would require months of repairs. Japan's carrier force, once seemingly invincible, had shown vulnerability. "Our construction programs must be accelerated," Nagano told his staff. "The Americans will be building carriers to replace their losses." What Nagano couldn't know was the scale of that replacement program. In American shipyards along both coasts, a revolution in naval construction was underway. The Essex program had been expanded from the original 7 ships to 24. Shipyards in Newport News, Philadelphia, Quincy, Brooklyn, and Norfolk were laying keels at a pace unprecedented in naval history. A recovered memorandum from the Japanese naval attaché in Portugal, dated August 1942, noted with concern, "Sources report American shipyards working 24 hours daily. Claims of 1 carrier per month seem exaggerated but warrant investigation." The report was flagged as potentially alarmist and filed without action. The idea that the United States could build carriers at such a rate seemed impossible to Japanese naval planners. Back at Kure, the Taiho's construction continued at a deliberate pace. Each component was carefully manufactured, each system meticulously installed. Quality was paramount. Construction would take 27 months from keel laying to commissioning, more than twice the time American shipyards would ultimately require for an Essex-class carrier. The contrasting approaches reflected fundamental differences in industrial philosophy. Japan's naval construction emphasized craftsmanship and individual excellence. Ships were essentially handcrafted, with components fitted and adjusted by skilled workers. American construction emphasized standardization and reproducibility. Components were manufactured to precise specifications, designed to be interchangeable across multiple vessels. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now back to the story. June 1942. The stunning Japanese defeat at Midway altered the strategic balance in the Pacific. 4 fleet carriers, Akagi, Kaga, Soryu, and Hiryu, were lost with their irreplaceable air groups and experienced crews. Japan's carrier advantage, the cornerstone of its naval strategy, vanished in a single day. In an emergency meeting at Imperial Headquarters, Admiral Nagano faced grim-faced colleagues. "How quickly can we replace these losses?" asked Prime Minister Tojo. The answer was sobering. Japan's shipyards could not rapidly replace carriers. The Taiho would not be ready until early 1943. 2 Hio-class carriers, converted from passenger liners, would be available sooner but were inferior fighting platforms. The converted battleships Issei and Hyuga would not be ready until 1943 and were poor substitutes for purpose-built carriers. "And what of the Americans?" Tojo pressed. "They lost Yorktown," Nagano replied. "We believe they have 3 fleet carriers remaining in the Pacific." What Japanese intelligence failed to grasp was the scale of American naval construction already underway. While Japan struggled to replace 4 carriers over the next 2 years, American shipyards would deliver 16 Essex-class carriers in the same period. The first, USS Essex herself, was launched just 1 month after Midway. The cause and effect relationship was becoming clearer. Japan's defeat at Midway had shifted the conflict from a tactical engagement to an industrial marathon. The question was no longer which navy had better carriers, but which nation could build them faster. November 1942. In the Yokosuka Naval Yard, Admiral Soemu Toyoda inspected the construction of the light carrier Chitose, a converted seaplane tender. Around him, workers struggled with material shortages. High-grade steel was increasingly scarce. Aluminum for aircraft production was strictly rationed. Critical components like radar sets and fire control computers were built in small batches by specialized facilities that couldn't be easily expanded. "We must do more with less," Toyoda told his staff. "America builds new ships while we convert old ones." A Japanese naval intelligence report from December 1942 noted with concern, "Essex launched ahead of schedule. Intelligence suggests sister ship Lexington also nearing completion. Yorktown name to be reused for third unit." The implications were disturbing but still not fully comprehended. Japan's naval leadership continued to believe quality would offset quantity. At Kure, the Taiho was finally taking shape after 16 months of construction. Her advanced features promised superior performance, but the strategic equation had shifted. By the time she would be commissioned, the Americans would have at least 3 Essex-class carriers in service, with more coming every few months. The contrasting industrial approaches were now producing visible results. Japan's craftsmanship-focused industry could produce exceptional individual vessels, but could not scale production to meet wartime demands. America's mass production approach could deliver standardized vessels at an unprecedented rate. March 1943. A captured American pilot was brought to the headquarters of the combined fleet. Among his personal effects was an astounding document, a copy of a magazine called Popular Mechanics, containing an article about American shipbuilding. The article, meant to boost home front morale, detailed the Essex construction program in surprising specificity. Admiral Minachi Koga, who had succeeded Yamato as commander-in-chief, studied the article with growing alarm. It described prefabrication techniques that allowed major components to be built simultaneously, then brought together for final assembly. It outlined the standardization that enabled multiple shipyards to build identical vessels. Most shockingly, it claimed that an Essex-class carrier could go from keel laying to commissioning in less than 15 months. "Is this possible?" Koga asked his staff. Naval constructor Captain Mitsuo Fuchida reluctantly nodded. "The Americans have adapted automobile assembly methods to shipbuilding. They build in modules, then join them together. We build from the keel up, step by step." The implications were staggering. Japan's naval strategy had assumed rough parity in carrier strength, or, at worst, a gradual American advantage. If the Americans could build carriers at the pace suggested by this article, Japan would face not just superiority, but overwhelming numerical dominance. Koga immediately ordered a comprehensive assessment of American shipbuilding capacity. The resulting report, delivered in April 1943, confirmed their worst fears. American shipyards were indeed building Essex-class carriers at a rate of 1 every 2 to 3 months. By the end of 1943, the Americans would have at least 7 in commission, with more to follow in 1944. The cause and effect relationship was now unmistakable. America's industrial capacity, converted to wartime production, was outbuilding Japan's shipyards by a factor of 5 or more. The qualitative advantages of ships like Taiho, even if real, could not possibly offset such numerical disadvantage. May 1943. The Taiho was commissioned after 27 months of construction. She was indeed an impressive vessel, incorporating all the lessons Japan had learned in carrier operations. Her armoured flight deck could withstand damage that would cripple earlier designs. Her enlarged air group gave her formidable striking power. She represented the pinnacle of Japanese carrier development, but by the time she entered service, the strategic situation had fundamentally changed. American shipyards had delivered 5 Essex-class carriers, with 8 more under construction. The industrial disparity was now manifest in actual ships at sea, not just production statistics. A bitter joke circulated among Japanese naval officers. We design the perfect carrier while the Americans build a perfect navy. The disparity extended beyond carriers. American shipyards were simultaneously building Cleveland-class cruisers, Fletcher-class destroyers, and hundreds of support vessels. Each program dwarfed Japan's corresponding efforts. The industrial imbalance affected every aspect of naval warfare: ships, aircraft, weapons, and trained personnel. December 14th, 1943. Aboard the battleship Yamato, Admiral Ugaki clutched the second set of captured Essex-class blueprints to his chest as he climbed the ladder to the Admiral's war room. These weren't fragments like before. They were complete assembly diagrams, showing the modular construction techniques that had mystified Japanese naval intelligence. After 6 staffers studied the drawings for hours, Captain Ohmae finally broke the silence. This isn't carrier construction, it's shipbuilding turned into factory production. The diagrams showed hull sections built simultaneously in different parts of the shipyard, engine components installed before hull completion, and prefabricated island structures lifted into place fully assembled. The Admiral stared at the build time estimate in the corner: 14 months from keel to commission. Japan's newest carrier, Taiho, had taken 27 months. "Can our shipyards adapt?" asked a young lieutenant. Ugaki closed his eyes before answering. "We don't have the industrial capacity. They've turned their automobile factories into shipyards. We're building traditional ships. They're manufacturing naval vessels like Mitsubishi makes trucks." July 1943, Pearl Harbor, Hawaii. The fleet at anchor was unrecognizable compared to 2 years earlier. Where once the shattered remains of battleships lay, now stood row after row of new construction aircraft carriers, cruisers, destroyers, and support vessels. The Essex, Yorktown, Intrepid, and Hornet swung at anchor, their flight decks bustling with aircraft. No other navy in history had recovered so quickly from such devastating losses. Admiral Chester Nimitz stood on a pier with his operations officer, studying the assembled fleet. 14 months ago, we had 2 carriers in the Pacific, Nimitz observed. Now we have 8, with more arriving monthly. What Nimitz couldn't know was the impact these ships were having on Japanese strategic planning. In Tokyo, the Naval General Staff was struggling to comprehend the scale of American production. Intelligence reports confirmed what seemed impossible: the Americans were commissioning a new Essex-class carrier approximately every 6 to 8 weeks. A translated fragment from a Japanese Naval Ministry assessment dated August 1943 revealed their growing alarm. American carrier construction has exceeded all projections. Our estimates indicate they will have 12 to 15 fleet carriers by mid-1944. Our construction program will deliver 2 to 3 inches the same period. The disparity cannot be overcome through tactical superiority alone. The cause and effect relationship was becoming painfully clear to Japanese leadership. America's industrial mobilization was creating a navy that would soon outnumber Japan's by an overwhelming margin. The quality versus quantity equation that had shaped Japanese naval thinking was now being tested in combat, and quantity was winning. September 1943. Yokosuka Naval Arsenal, Japan. Admiral Koga toured the shipyard with growing concern. The carrier Unryu was under construction, the first of a new class designed to replace Midway losses. But progress was slow. Steel deliveries were delayed. Skilled workers had been drafted for army service. Power outages disrupted welding and machining operations. "When will she be completed?" Koga asked the yard superintendent. "April 1944 at the earliest," came the reply. "The Americans will have commissioned 5 more Essex carriers by then." The industrial disparity was becoming visible in every aspect of naval construction. American shipyards operated around the clock, with 3 shifts of workers. Japanese yards struggled to maintain a single full shift as resources dwindled. American yards used standardized designs and prefabricated components. Japanese yards still relied on traditional methods, building each ship as a unique creation. A Japanese naval intelligence report from October 1943 described the contrast. American shipbuilding has been transformed into a form of mass production. Components are built in inland factories, then transported to shipyards for assembly. Their system resembles automobile manufacture more than traditional shipbuilding. We cannot match this approach with our current industrial base. This report touched on the fundamental difference in construction philosophy. American shipyards had adopted assembly line techniques, building identical components in large numbers, then bringing them together for final assembly. Japanese yards continued to build ships from the keel up, with components crafted individually for each vessel. The results were starkly different. An Essex-class carrier typically required 14 to 17 months from keel laying to commissioning. Japan's carriers required 24 to 30 months for the same process. The quality of Japanese construction remained high, but the quantity disparity was becoming insurmountable. November 1943. Imperial General Headquarters, Tokyo. Admiral Nagano presided over a strategic assessment meeting. The situation map on the wall told a grim story. American forces were advancing across the Central Pacific. New carriers were appearing faster than intelligence could track them. The strategic initiative, once firmly in Japanese hands, had shifted decisively to the Americans. "We must face reality," Nagano told the assembled officers. "We cannot match American production. Our strategy must adapt accordingly." What Nagano proposed was a fundamental shift. Instead of seeking decisive battle with the American fleet, the cornerstone of pre-war Japanese naval doctrine, the Imperial Navy would focus on attrition. Submarines, aircraft, and land-based forces would target American carriers, hoping to sink enough to offset the production disparity. A senior staff officer objected, "But their industrial capacity is beyond our ability to counter directly." Nagano interrupted. "We must seek to raise their costs, extend their supply lines, and exploit any tactical opportunities. We cannot win a war of production." Strategic shift represented tacit admission of what the captured Essex blueprints had revealed. Japan could not match American industrial output. The quality of Japanese ships, the skill of Japanese pilots, the bravery of Japanese sailors, none of these could overcome the fundamental industrial disparity. December 1943. The moment that opened our story. Admiral Ugaki examining the complete set of Essex blueprints in his quarters aboard Yamato. What shocked him wasn't just the modular construction techniques, though these were impressive. It was the standardization, the ability to build identical ships in multiple shipyards simultaneously. Ugaki summoned his chief of staff and naval constructor. "Could we adopt these methods?" he asked. The naval constructor, Commander Hitoshi Imamura, studied the drawings before responding. "Not with our current industrial base, Admiral. Their approach requires massive steel production, standardized component manufacturing, and shipyards designed specifically for assembly rather than construction. How much of our difficulty is technical and how much is organizational?" Ugaki pressed. Imamura was honest. "Both, Admiral. We lack their steel production capacity, but we also lack their systems approach to manufacturing. Our naval construction remains essentially artisanal, skilled craftsmen building individual ships. Theirs has become industrial standardized components, assembled by less skilled workers following detailed procedures." The cause and effect relationship was now fully visible. America's industrial advantage wasn't just about raw production capacity, though that was substantial. It was about a fundamentally different approach to manufacturing, one that Japan could not quickly adopt even if resources were available. January 1944. Kure Naval Base, Japan. The carrier Taiho prepared for deployment. She represented everything the Imperial Navy valued: superior design, meticulous construction, and advanced features. Her armored flight deck, improved damage control systems, and enhanced air group made her, on paper, superior to any single Essex-class carrier. But as Admiral Jisaburo Ozawa watched from the pier, he understood the strategic reality. For every Taiho, the Americans now had 6 Essex-class carriers. Quality might triumph in a single engagement, but quantity would prevail in a prolonged campaign. And the war in the Pacific had become exactly that, a grinding campaign where industrial capacity mattered more than individual ship quality. A message from naval intelligence arrived during Ozawa's inspection. It confirmed that 2 more Essex-class carriers, Hancock and Ticonderoga, had been commissioned. 2 more Randolph and Shangri-La would follow within months. The message included a startling statistic. American shipyards were now producing more carrier tonnage every 2 months than Japan had built in the 2 years since Pearl Harbor. The strategic implications were inescapable. Japan could not win a naval war against such production capacity. Individual victories might be achieved through superior tactics or temporary advantage, but the overall trend was irreversible. The Essex production program alone would ensure American naval dominance by sheer weight of numbers. February 1944. Naval Ministry, Tokyo. A captured American technical journal circulated among senior officers. The article, from the U.S. Naval Institute Proceedings, described the standardization that enabled rapid Essex construction. Every carrier in the class had identical machinery arrangements, electrical systems, and structural components. Parts from one ship could be used in any other. Construction teams could move between shipyards and immediately understand the work because the plans were uniform across all building sites. Admiral Mitsumasa Yonai, the Navy Minister, called a meeting of construction bureau chiefs after reading the article. Could we implement similar standardization? He asked. The answers were discouraging. Japan's shipbuilding tradition emphasized customization and continuous improvement. Each carrier incorporated lessons from previous vessels, making them better individually but harder to build in numbers. Different shipyards used different construction methods. Components were crafted for specific ships rather than built to universal specifications. A senior bureau chief summarized the problem. We would need to redesign not just our ships, but our entire industrial system. It would take years we do not have. The cause and effect relationship was structural and historical. Japan's approach to naval construction had evolved from its particular industrial traditions, emphasizing craftsmanship, continuous improvement, and individual excellence. America's approach had evolved from its mass-production industrial base, emphasizing standardization, interchangeability, and volume. In peacetime, both approaches had merit. In wartime, the American system held a decisive advantage. March 1944. Truk Lagoon, Caroline Islands. Admiral Ugaki stood on Yamato's bridge, watching a formation of carrier aircraft on patrol. These were the planes of the light carrier Chitose, one of the converted seaplane tenders pressed into service to offset carrier losses. She was a poor substitute for a purpose-built fleet carrier, smaller air group, slower speed, less protection. But she was available, while new construction carriers were still months or years from completion. Ugaki's chief of staff approached with a signal form. Intelligence confirms 2 more Essex carriers have joined the American Pacific Fleet, he reported. They now have 14 fleet carriers in theater. We have 5. The numerical disparity was now overwhelming. Even counting light carriers and converted vessels, Japan could not match American carrier strength. The quality advantage that Japan had counted on superior aircraft, better trained pilots, more experienced crews had eroded as the war progressed. American aircraft had improved. American pilots, once inexperienced, had accumulated combat time. American tactics had adapted to counter Japanese strengths. What remained unchanged was the industrial disparity. American shipyards continued to launch new carriers at a pace Japan could not approach. The strategic equation had shifted decisively and irreversibly. April 1944. Imperial Conference, Tokyo. Admiral Nagano presented a stark assessment to Emperor Hirohito and the government leadership. The naval situation had deteriorated beyond recovery. American carrier strength now outnumbered Japan's by a factor of nearly 3 to 1. By year's end, that disparity would increase to 5 to 1 or greater. We cannot match their production capacity, Nagano concluded. Our naval strategy must acknowledge this reality. The Emperor, normally reserved in such meetings, asked a direct question. Could we have foreseen this industrial disparity? Prime Minister Tojo attempted to deflect the question, but Nagano answered honestly. The potential was visible in pre-war production statistics, Your Majesty. American steel production exceeded ours by a factor of 10. Their automobile industry, now converted to war production, outproduced our entire industrial base. We understood they could build more ships, but we believed quality would offset quantity. We were mistaken. The cause and effect relationship had become a strategic reckoning. Japan had entered the war believing its qualitative advantages would counter American quantitative superiority. That calculation had failed to account for how quickly American industry could convert to war production, how effectively American shipyards could scale carrier construction, and how thoroughly American industrial methods could transform naval manufacturing. May 1944. Kure Naval Base, Japan. The carrier Unryu finally completed sea trials and joined the fleet, 16 months after her keel was laid. She was a simplified design based on the pre-war Hiryu, built to accelerate construction. Even with these simplifications, her construction had taken longer than an Essex-class carrier of greater size and complexity. Admiral Ozawa inspected the new carrier with mixed emotions. She was a welcome addition to his diminished carrier force, but her arrival highlighted the production disparity. During the 16 months of her construction, American shipyards had delivered 9 Essex-class carriers. The gap was widening, not narrowing. A naval intelligence summary delivered during Ozawa's inspection contained troubling information. American shipyards weren't just building Essex-class fleet carriers. They were simultaneously constructing Independence-class light carriers converted from cruiser hulls. 9 had already been completed. Additionally, escort carriers, smaller vessels for convoy protection and amphibious support, were being built at an even faster rate. The Casablanca class alone comprised 50 ships, all completed within a 2-year period. The industrial mismatch had reached staggering proportions. Japan's entire wartime carrier construction program would deliver fewer ships than American yards completed in a 6-month period at peak production. June 1944. Philippine Sea. The largest carrier battle of the war unfolded as Admiral Ozawa's mobile fleet confronted the American Fifth Fleet. The battle would become known to Americans as the Great Marianas Turkey Shoot. Due to the lopsided aircraft losses, the Japanese lost over 300 planes, while American losses were minimal. What made the outcome so decisive wasn't just tactical execution or pilot quality. It was the industrial disparity made manifest in combat power. Ozawa commanded 9 carriers of various types. Admiral Raymond Spruance's Fifth Fleet included 15 fleet carriers plus 8 light carriers. The American advantage in aircraft was similarly overwhelming, nearly 900 planes to Japan's 450. Even more telling was what the battle revealed about industrial depth. American carriers operated with abundant resources, ample fuel for combat air patrols, plentiful replacement aircraft, extensive radar coverage, and comprehensive communications. Japanese carriers, constrained by resource limitations, operated with minimal reserves and restricted communications. After the battle, Ozawa submitted a report to Imperial Headquarters. His assessment was unsparing. The disparity in carrier strength is now decisive. We cannot match their numbers, their aircraft quality, or their logistical support. Each engagement further depletes our limited resources, while they operate from a position of industrial abundance. The cause and effect relationship had reached its logical conclusion. The industrial disparity visible in the Essex blueprints had manifested as overwhelming combat power. The strategic gamble that quality could offset quantity had failed comprehensively. July 1944. Admiral Ugaki's personal diary, recently discovered in archives and translated, contained a striking entry from this period. We built magnificent ships one by one, while they built adequate ships by the dozen. We crafted carrier vessels. They manufactured a carrier fleet. The difference proves decisive. This private assessment captured the essence of Japan's strategic miscalculation. The Navy had designed its ships as individual masterworks, emphasizing quality and performance. America had designed its ships as industrial products, emphasizing standardization and production efficiency. In peacetime, Japan's approach produced excellent vessels. In wartime, America's approach produced overwhelming numbers. The Essex program exemplified this difference. The design was deliberate, not the most innovative carrier possible, but an excellent balance of capability and buildability. Every aspect was engineered for mass production. Hull sections were standardized. Machinery arrangements were identical across all ships. Components were interchangeable. Construction sequence was optimized for assembly line efficiency. The result was a production miracle. Between December 1942 and September 1945, American shipyards delivered 24 Essex-class fleet carriers. Japan's entire wartime program completed 6 fleet carriers in the same period. The disparity was beyond tactical compensation. It represented a fundamental mismatch in industrial capacity and manufacturing philosophy. August 1944. Imperial Naval Staff College, Tokyo. Captain Atsushi Oi, a naval constructor and instructor, delivered a lecture analyzing the Essex program. His conclusions were sobering for the assembled officers. The Americans designed the Essex-class specifically for mass production, Oi explained. The arrangement of internal spaces, the dimensions of structural members, the configuration of machinery, all were standardized to enable rapid construction by multiple shipyards simultaneously. A senior officer objected, "But surely our carriers are technically superior." Oi was direct. "In some aspects, yes. Our damage control is more advanced. Our flight deck arrangements are excellent, but these advantages cannot overcome a 6-to-1 numerical disparity, and their carriers, while standardized, are remarkably capable vessels. The Essex class has proven adaptable and resilient in combat." The lecture continued with detailed analysis of American production methods. Oi described how shipyards had adopted automotive assembly techniques, building major components in parallel rather than in sequence, using standardized jigs and fixtures to ensure consistency and employing interchangeable parts throughout the vessel. Their shipbuilding is no longer a craft, Oi concluded. It is industrial manufacturing applied to naval vessels. We cannot match this approach with our current industrial base and construction philosophy. The cause and effect relationship was now understood, at a technical level. America's industrial advantage wasn't just about raw capacity. It was about a fundamentally different approach to manufacturing, one that Japan had neither the infrastructure nor the institutional flexibility to adopt quickly. September 1944. Kure Naval Yard, Japan. Construction on the carrier Kasagi proceeded slowly amid resource shortages. Steel deliveries were irregular, skilled workers were increasingly scarce. Power outages disrupted welding and machining operations. The yard superintendent knew she would not be completed before the war's end, but work continued nonetheless. A senior officer passing through the yard stood silently beside a massive steel hull section. "Will she ever sail?" he asked quietly. The superintendent wiped his brow. "Construction is at 26%. At current pace, we need another 18 months. The Americans launched 5 carriers in that time," the officer replied. The superintendent had no answer. Nearby, a group of naval engineers studied photographs of the USS Intrepid after surviving multiple kamikaze strikes. The carrier had absorbed tremendous damage yet returned to service within weeks. American damage control and repair capabilities, backed by their industrial base, allowed them to quickly restore damaged vessels. A Japanese naval intelligence report from this period noted, "The Americans treat battle damage as a logistical problem rather than a technical challenge. Their standardized construction allows rapid repair using pre-manufactured components. Their ability to return damaged carriers to service often exceeds our ability to complete new construction." The cause and effect relationship extended beyond initial construction to include battle damage repair. Standardized designs meant standardized repair procedures. Interchangeable components meant damaged sections could be replaced rather than rebuilt. The industrial philosophy that enabled mass production also enabled rapid repair. October 1944. Leyte, Gulf, Philippines. The largest naval battle in history unfolded as Japan committed its remaining fleet strength in a desperate attempt to disrupt the American landing operations. The battle ended in decisive American victory despite some initial Japanese tactical successes. Admiral Takeo Kurita's after-action report contained a passage that captured the industrial disparity in stark terms. "We achieved tactical surprise and inflicted damage on several American carriers. They withdrew these vessels and replaced them with fresh carriers from their reserve. We have no such reserve. Each vessel lost or damaged represents irreplaceable combat power." This observation highlighted another advantage of American industrial capacity. The Essex program had created not just numerical superiority, but strategic depth. Damaged carriers could be withdrawn for repair while fresh vessels took their place. The American carrier force maintained constant pressure despite combat losses and battle damage. The Japanese Navy had no comparable depth. Each carrier loss was permanent. Each damaged vessel represented a significant reduction in overall capability. The industrial disparity had created not just a numerical advantage, but a fundamental strategic asymmetry. November 1944. Imperial Naval Headquarters, Tokyo. The captured Essex blueprints that had so shocked Admiral Ugaki a year earlier were now the focus of an intensive study group. Naval constructors and industrial engineers examined every aspect of the American design, seeking insights that might be applied to Japanese construction. Captain Keizo Komamura, who led the study group, presented his findings to the Naval General Staff. "The Essex design represents a fundamentally different approach to naval construction," he explained. "Every aspect prioritizes production efficiency without sacrificing essential combat capability." Komamura highlighted several key features. The use of straight-line hull sections wherever possible, to simplify fabrication, the standardized machinery arrangements to enable parallel assembly, the modular island structure that could be built and equipped separately, then installed as a unit, the identical internal compartmentation across all ships of the class. Most significantly, Komamura concluded, the entire design was created with mass production as a primary requirement, not an afterthought. Our designs prioritize individual performance and are then adapted for production. Their design process integrated production considerations from the beginning. A senior admiral asked the inevitable question, could we adopt similar methods now? Komamura was direct. Not without fundamental changes to our industrial infrastructure, our workforce training, and our design philosophy. Such changes would require years we do not have, and even then, we lack the raw material capacity to match their production volume. The cause and effect relationship was now fully documented. America's industrial advantage stemmed from both quantitative factors, steel production, workforce size, energy capacity, and qualitative factors. Production methods, standardization approaches. Japan could not address either dimension quickly enough to affect the war's outcome. December 1944. Kure Naval Base, Japan. The carrier Amagi, another of the Unryu class, completed fitting out and prepared for sea trials. Like her sister ships, she represented the best Japan could produce under wartime constraints, a simplified design built as quickly as possible with available resources. Admiral Toyoda inspected the new carrier with a small staff. The ship was well built despite material shortages. Her lines were clean. Her flight deck was spacious for her size. But Toyoda knew her limitations. Her aviation fuel capacity was restricted by material shortages. Her damage control systems were simplified. Her anti-aircraft armament was less than originally planned. During the inspection, a staff officer delivered an intelligence report. It detailed American carrier operations off the Philippines, continuous airstrikes, around-the-clock flight operations, abundant fuel and ordnance expenditure. The report concluded with a devastating statistic. The American Fast Carrier Task Force had launched more aircraft sorties in the previous month than all Japanese carriers combined had launched in the preceding year. The industrial disparity had translated directly into operational capability. American carriers operated with seemingly unlimited resources, abundant fuel, plentiful ordnance, regular aircraft replacements. Japanese carriers were constrained at every level, fuel was strictly rationed, ordnance was limited, aircraft replacements were increasingly scarce. January 1945. Naval Ministry, Tokyo. A comprehensive assessment of the Essex program was completed for the Naval General Staff. The document, running to several hundred pages, analyzed every aspect of American carrier construction, design features, production methods, resource allocation, workforce management, and operational capabilities. The assessment's conclusions were unsparing. The Essex program represents industrial mobilization on a scale we cannot match. Their ability to design, build, and deploy 24 fleet carriers in a 4-year period demonstrates production capacity approximately 8 times our maximum capability. More troubling were the assessment's observations about industrial philosophy. The Americans approach shipbuilding as mass manufacturing rather than craft production. This fundamental difference cannot be overcome through incremental changes to our current methods. It would require comprehensive reorganization of our entire industrial base, a transformation impossible under wartime conditions. The cause and effect relationship was now documented in exhaustive detail. America's advantage wasn't simply about resources, though these were substantial. It was about a fundamentally different approach to industrial production, one that Japan had neither the infrastructure nor the institutional flexibility to adopt quickly. February 1945, Kobe, Japan. A B-29 bombing raid damaged the shipyard where the carrier Kasagi was under construction. Work, already proceeding slowly due to material shortages, halted completely. The yard superintendent knew she would never be completed. As workers cleared debris, a naval officer discovered a fragment of the Essex blueprints that had fascinated Japanese naval leadership. The paper was charred around the edges, but the drawing was still visible, a cross-section showing the modular construction technique that had enabled American shipyards to build carriers at unprecedented speed. The officer carefully preserved the fragment. It had become more than a technical drawing. It was a symbol of the industrial disparity that had decided the naval war before the first shot was fired. March 1945. Yokosuka Naval Base, Japan. The carrier, Katsuragi, last of the Unryu class to be completed, joined the fleet after nearly 2 years of construction. She was immediately camouflaged and dispersed to avoid air attack. With fuel reserves critically low, she would never conduct flight operations or sortie for combat. A staff meeting aboard the flagship Yamato addressed the carrier situation frankly. Of Japan's remaining carriers, none had full air groups. Pilot training had been curtailed due to fuel shortages. Aircraft production could not keep pace with losses. The once mighty carrier force that had struck Pearl Harbor was reduced to a hollow shell. Admiral Toyoda received a final intelligence assessment of American carrier strength. The numbers were staggering. 21 Essex-class fleet carriers in commission or final fitting out. 9 Independence-class light carriers operational. Over 50 escort carriers supporting amphibious operations and anti-submarine warfare. The total American carrier force now outnumbered Japan's by more than 15-1. The industrial disparity had reached its maximum expression. The Essex program alone had produced more carrier flight deck area than Japan's entire pre-war and wartime construction combined. The strategic gamble that quality could offset quantity had failed comprehensively and irrevocably. April 1945. Inland Sea, Japan. The battleship Yamato departed on her final mission, a one-way suicide attack against American forces off Okinawa. The sortie represented the end of Japanese naval strategy. With carriers ineffective due to aircraft and pilot shortages, the surface fleet was being sacrificed in a desperate gesture. Admiral Ugaki, who had been so shocked by the Essex blueprints 16 months earlier, volunteered to accompany the mission, but was ordered to remain behind. He recorded in his diary, "We built magnificent ships one by one. They built powerful navies by the fleet. The difference proves decisive." As Yamato departed, American carrier aircraft were already airborne to intercept hundreds of planes from multiple Essex-class carriers operating as a coordinated force. The industrial disparity had created not just individual ships but an integrated system of naval power that Japan could no longer challenge. May 1945. Naval Staff College, Tokyo. Despite the deteriorating war situation, educational functions continued. Captain Masataka Chihaya, a naval constructor, delivered what would be the final lecture on the Essex program. His analysis went beyond technical details to address fundamental questions of industrial philosophy. The Americans approach naval construction differently, Chihaya explained. They ask not what is the best possible ship, but what is the best ship we can build in large numbers quickly. This perspective shapes every aspect of their design process. Chihaya displayed comparative statistics. An Essex-class carrier required approximately 13,000 tons of steel. Japan's steel production, in 1944, totaled roughly 4 million tons. American production exceeded 80 million tons. This disparity meant that steel allocation for naval construction represented a major commitment for Japan, but a relatively small fraction of capacity for the United States. Even if we had adopted their production methods, Chihaya concluded, we lacked the raw material base to match their output. The disparity was not just in how we built ships, but in our capacity to produce the materials from which ships are built. The cause and effect relationship encompassed the entire industrial ecosystem: raw material production, component manufacturing, assembly methods, workforce training, and design philosophy. The Essex program succeeded because it was supported by the world's largest industrial base, designed specifically for mass production, and executed with a clear focus on quantity alongside quality. June 1945. Maizuru Naval Arsenal, Japan. Construction on the carrier Aso, authorized in 1942, had never progressed beyond laying the keel. Material shortages, workforce depletion, and power restrictions had rendered the project theoretical rather than practical. Now, with Allied bombing intensifying, even the pretense of continuation was abandoned. A naval constructor surveying the abandoned worksite reflected on what might have been. Had ASO been completed, she would have incorporated lessons from combat experience, improved damage control, enhanced anti-aircraft defenses, better flight deck arrangements, but she would still have been one ship against an American carrier fleet that now dominated the Pacific. July 1945. Tokyo Bay, Japan. The carrier Katsuragi lay camouflaged and immobile, conserving her last fuel reserves. Her air group consisted of a handful of obsolescent aircraft. Her crew trained with minimal resources. She was technically operational but practically ineffective, a symbol of Japan's naval exhaustion. Aboard an American Essex-class carrier offshore, flight, operations continued around the clock. Aircraft were launched, recovered, rearmed, refueled, and launched again in a continuous cycle. Fuel was abundant. Ordnance was plentiful. Replacement aircraft arrived regularly. The industrial might of the United States was projected forward through these floating airfields. The contrast could not have been starker. One navy operated from industrial abundance, the other from resource exhaustion. One launched hundreds of sorties daily, the other preserved aircraft for a final defensive effort. One represented mass production triumphant, the other craft tradition in terminal decline. August 1945. Naval Ministry, Tokyo. The final assessment of the Essex program was completed days before Japan's surrender. The document was never formally presented but survives in archives. Its conclusions were stark and unequivocal. The Essex-class carrier program represents the decisive factor in the naval war, the assessment stated. No tactical brilliance, technological advantage, or fighting spirit could overcome the industrial disparity it represents. The Americans designed not just a superior carrier, but a superior production system. The assessment detailed the production achievement in cold statistics. 24 Essex-class fleet carriers completed or nearing completion. Construction times averaging 14 to 16 months per vessel. Total flight deck area exceeding 30 acres across the class. Combined air groups approaching 2,000 aircraft. The industrial mobilization behind these numbers was even more impressive. Steel production exceeding 80 million tons annually. Aircraft production reaching 100,000 planes yearly, and workforce expansion that added millions of new shipyard workers. We studied their carriers to understand their naval strategy, the assessment concluded. We should have studied their factories to understand their war-making capacity. September 1945. Tokyo Bay, Japan. The surrender ceremony aboard the USS Missouri marked the formal end of the conflict. The Missouri, an Iowa-class battleship, represented American industrial power as clearly as any Essex-class carrier. She had been built in 3 years alongside 8 sister ships, while simultaneously constructing dozens of carriers, hundreds of cruisers and destroyers, and thousands of landing craft. Aboard the Japanese delegation vessel, several naval officers who had studied the Essex program watched American carriers operating in the distance. The industrial disparity that had so shocked them when first revealed in captured blueprints was now visible in overwhelming force. October 1945. Office of Naval Intelligence, Washington, D.C. American technical analysts completed their final assessment of Japanese naval construction. The report acknowledged the quality of Japanese shipbuilding, but noted the fundamental limitation. Japanese naval construction remained essentially a craft tradition rather than an industrial process. Their vessels were individually excellent, but could not be produced in sufficient numbers to affect the strategic balance. The report highlighted the philosophical difference. American shipbuilding adapted automotive mass production techniques to naval construction. Japanese shipbuilding retained traditional methods enhanced by modern technology. The former enabled rapid scaling, the latter did not. This assessment captured the essence of the industrial disparity. It wasn't simply about resources, though these were dramatically unequal. It was about fundamentally different approaches to manufacturing, one optimized for individual excellence, the other for production volume without sacrificing essential quality. November 1945 to February 1946. United States Strategic Bombing Survey teams interviewed Japanese naval officers about the impact of the Essex program on strategic planning. Admiral Ugaki, who had been so shocked by the captured blueprints, provided particularly valuable insights. When we understood the scale of American carrier construction, we recognized that our pre-war strategy was invalidated, Ugaki explained. We had planned for a decisive battle against a roughly equal force. The Essex program ensured we would always face overwhelming numerical superiority. Asked when Japanese leadership recognized the significance of American production capacity, Ugaki was candid. We understood it intellectually before the war. We saw it in your steel production statistics, your automobile manufacturing, your industrial expansion, but we did not truly comprehend its meaning until we captured those Essex blueprints and realized you were building carriers like Ford built cars. The cause and effect relationship between industrial capacity and naval power had been demonstrated conclusively. America's ability to design ships for mass production, build them in multiple shipyards simultaneously, and support them with an integrated logistics system had created not just numerical superiority but strategic dominance. March 1946. Naval War College, Newport, Rhode Island. A comprehensive study of the Essex program was prepared for future naval architects and strategists. The study emphasized how the program had balanced 3 critical factors: combat capability, production efficiency, and operational sustainability. Combat capability ensured each carrier was an effective fighting platform. The Essex design incorporated lessons from early war experience, enhanced protection, improved damage control, expanded air group capacity, and strengthened anti-aircraft defenses. Despite being designed for mass production, the carriers were individually powerful vessels. Production efficiency enabled rapid scaling. The design used standardized components, modular construction techniques, and parallel assembly methods. Multiple shipyards could build identical vessels simultaneously, sharing workforce knowledge and manufacturing techniques. Construction time was minimized without compromising structural integrity. Operational sustainability ensured the carriers could be maintained in forward areas with minimal support infrastructure. Standardization meant parts were interchangeable across the class. Common systems simplified crew training and maintenance procedures. The design anticipated battle damage and facilitated rapid repair. The Essex program succeeded, the study concluded, because it integrated combat requirements, production considerations, and operational factors from the beginning. It was not merely a good carrier design, it was a good mass-production carrier design. April 1946, Yokosuka Naval Base, Japan. American occupation authorities conducted a final inventory of Japanese naval assets. The carrier Katsuragi, once proud symbol of Japanese naval aviation, was designated for scrapping. Her construction had required nearly 2 years of intensive effort. She had never launched an operational airstrike. Nearby, an American Essex-class carrier conducted routine flight operations. From keel laying to commissioning, she had required 14 months to complete. She was one of 24 sisters, the most numerous class of fleet carriers ever built. Together, they had formed the backbone of the most powerful naval force in history. The industrial disparity was now complete. The Japanese carriers that had struck Pearl Harbor were resting on the ocean floor. The American carriers that had replaced those lost on December 7th had gone on to win the Pacific War through overwhelming force. The Essex program had transformed naval warfare from a contest of skill and courage to an expression of industrial might. May 1946, Pentagon, Washington, D.C. A final assessment of the Essex program was prepared for Navy leadership. The document emphasized not just the military significance of the carriers but their demonstration of American industrial capability. The Essex program represents more than naval construction. The assessment stated, "It demonstrates our ability to identify a critical requirement, design an appropriate solution, and execute production at unprecedented scale. This capacity to transform industrial might into specific military power rapidly and efficiently may be the most significant strategic advantage we possess." This observation captured the essential lesson of the program. The 24 Essex-class carriers were impressive vessels individually. Collectively, they represented something more profound, the ability of American industry to produce overwhelming military power in response to strategic necessity. The cause and effect relationship between industrial capacity and military power had been demonstrated conclusively. Future conflicts would be shaped by this reality. Naval supremacy, once determined by seamanship and courage, was now fundamentally an industrial question: who could build the most effective fleet most quickly? The Essex program had answered that question decisively. The captured blueprints that had so shocked Admiral Ugaki were not just technical drawings. They were the visible expression of an industrial capacity that had transformed naval warfare forever. The 24 carriers built in 4 years had not just won a war, they had demonstrated a new reality that modern conflict would be decided as much in factories as on battlefields. Japanese admirals had understood this truth too late. When they studied those captured Essex plans in December 1943, they finally recognized what they were truly fighting: not just America's Navy, but America's industrial might. The realization came too late to change their strategy, but not too late to understand why they had already lost the war. Up next, you've got 2 more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out, and don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.